Okay, so this section, section 3.7, has to do with the mid-segments of triangles and trapezoids. So you graph a triangle and you graph a trapezoid. Okay, so we're going to look at that first. This is your activity that's in the book to explore what you notice about these things. Okay, so we're just starting with that. It'll show it on our notes in just a minute, but when you were graphing, when you were graphing, you had all positive numbers. Okay, so if you followed what it said, okay, if not, we're trying it right now. You graph the points, and then it said to find the middle of segment AB. Okay, so you found the middle, but you could hold it or count, I guess you could do that as well. But found the middle of that, and then you labeled that as M. Okay, so I'm just going to draw. Let me get a blank. What you have on here. This is a sketch, obviously, because I'm not going to have graph paper up here. Okay, so we just had one quadrant, and you had 0, 0, you had 8, 8, and then 16, 0, I believe is what it was. This one was your A, this one was your B, and then this one was your C. Okay, so we have our triangle. And you were supposed to fold A and B to find the middle, and then you label that as what? M. Okay. And then we did the same thing now for AC, so we fold and matched up those points to find the middle, okay? And then we label that as M. Okay, so your next step was to be able to answer those questions and fill in the blanks. We're going to make sure we got the right answers. If we don't, then we're just going to change it, okay? So we needed to find the length from M to N. Okay, now remember, you don't start counting until you actually move. For some reason, people get stuck on that. They say this is 1. You can't count until you move. So you can move over. And this should be on, you know how you have a bunch of these guys? It should be right here. You might be off a bit because when you draw your line, it might not have been straight. So make sure you're starting at where the intersection point on the graph is at. Okay, so you're counting over until you get to N. What did you get? 8. Should have got 8. We didn't change it, okay? So filling in, you have on number 5 on your notes, it says the measure of MN. So you should have 8. Okay, and then you were supposed to find the measure of BC. So same thing, counting on this one, you're just counting all the boxes until you get to the other one, which is 16. Okay, right? Because it was started at 0 and the coordinates were 16, 0. So you had to count over 16. Okay. And then below that, this is where we're filling it in. Describe what you notice about those two numbers. If you were to compare those two numbers, how are they related to each other? Yeah. 8 is half of 16. Okay. Or vice versa, you could double it, right? Okay. So you could write either of these because both of them are true. Actually, let's write both of them. Okay, we're going to write MN is half of BC. Okay, or BC is 2 times. Okay, so on number 5 below where we wrote those numbers, you're going to write those two numbers.
Ken, please come to the office. Ken, please come to the office.
Okay, so now we're going to do the same thing now for the trapezoid. Okay, they still need that. Okay, again, we still have positive numbers. So we had it graphed. So you had 1, 1, 2, right? So 1 up 2. And that was your D. And then over 7, and again, I'm just sketching up 10. And that was your A. And then your E was at 12, 10. And then your C was at 18, 2. And that was your C. Okay, so then we would draw our trapezoid. Okay, so now this time we have 3 segments. So we had to find the middle of AB, just like we did with the triangle. Okay, so we folded A, matched it up with B, and found the middle of that. Okay, and we labeled that M again. And then you folded B, match up with C to find the middle again and labeled that as N. Okay, so we have 3 segments that we're finding the length of. Okay, what did you get? What's the first one I asked us for AB? 5. Okay, got 5. Okay, what did you get for MN? What? Anybody? 11. Yeah. Because if it's not right, then we'll change it. Wow, twinsies. Okay, bottom one. 17. Okay, now, as a hint, if you were to combine, bless you, the top number and the bottom number, okay, combine those, how is it related to the middle number? Top number and the bottom number, if you were to combine those two, how would it be related to that middle one? It's a half of 11, right? So 17 and 5 give us 22, right? And so it's the same thing, similar to the same thing as your triangle. Okay, we're just missing this top part. Okay, so we only have one line to worry about. Okay, so we're going to put, where you got your space down here? I'll write it down here. So when you combine the two, and we're going to write it as AB plus BC. MN is half of the two combined. Okay, so now back to our notes and filling in some of our vocab. Anybody still writing that? Okay. So in our drawing where the book starts out, and this is one of the questions that is actually in the book, we have a pyramid here, okay? So it says that you could actually determine where halfway up is, okay? If we know the base, okay, we know the base here, and we know what the length of right here is. We could figure out what the middle is going to be without having to like actually measure the height of it. Okay, we would measure the base and we can measure the top, and then you would add those two, and that would divide by 2, and that would tell you where the middle, the width of the middle of that trapezoid is. Okay, and so that was just the example that was in the book. Okay, and you'll have questions like that. Okay, so our first definition that you should have written down. It said, now turn to page 183 in your book. So if you didn't get these, now's the time to be writing these, so you don't have to do it later. Okay, so it says write the definition of the mid-segment of a triangle. Okay, so we have a mid-segment of a triangle is a segment whose endpoints are the midpoints of the two sides. Okay, so back to your drawing. We're going to add some tick marks to our drawing. So go to your triangle drawing that was on your graph paper. Okay, midpoint means it does what to that segment? Splits it in half. So you kind of had a question like this on your test that you took. Oh, I did have graph paper. It's not the one I just did. You had a question like this on your test that you took yesterday where they were asking what if those two intersect each other, what do you notice? What are the two segments that are congruent to each other? And it was because it split it in half. It was the midpoint. And they used the word midpoint. Okay? So on your triangle, even though we know this one and this one are the same length, we're going to mark them different because you won't always have the same length ones on your worksheets, okay? So this one, when we matched A up with B, we put M there because we found the middle, okay? So that means that from A to M, okay, we're going to put a tick mark, is the same as M to B, okay? Because some of these they'll ask you, they'll say, don't write this part, write those tick marks. They might say this is 2, and they want you to find this, the length of this segment. Or they might want you to find the full segment. Okay, so we know that this middle splits this side in equal parts. Okay, and then the same thing is true over here. So we're just going to put different tick marks over here. Another type of question that you'll come across is they want you to find the middle, or they'll ask you, is that the middle? Okay, so if you had, again, don't write this next part. If you had 6, they said the length of this was 6, and the length of this is 7. Then they'll ask you, is that the middle of that? And it would be a no, because it would have to be equal lengths, okay? And then the same thing over here, so that would be wrong. It would probably be the same one. Okay. So, going to, I got that one. Okay, so on your drawing, we already marked these, we already marked that. You're going to put a 1 here, a 2 here, a 3 here, and a 4 here. And we're just classifying those instead of by numbers or letters. Saying the angle measurement, we're going to say look at angle 1. Okay, that's what those are. So 1, 2, 3, and 4. Okay, so we found what the middle was now, so we know that the sides are congruent to each other. In this section, they'll also ask you about angles. Okay, what do you think is true about this line and this line? Parallel. Okay, so what do we call this line? Transversal. So what do I know about angles 1 and 2? They're what? They're the same. Okay, so next to your drawing that you have, you're going to write angle 1 is congruent to angle 2. Okay, so now we actually have a different transversal on the other side. So what also would be true? Angle what? 3 and 4. What else? So just next to your drawing, writing that. We good? Okay, what would happen if I know this one and they actually want you to find this one? If these are parallel lines and this is a transversal, what do we know about this one and this one? They add to equal 180. So sometimes they might ask you for some, like all of the angles, okay? You would know this one and this one are the same, this one and this one are the same. You would know that this one and this one add to equal 180, which would also be true about this one and this one would add to equal 180. Well, what would I do if I wanted to find that?
And the bottom too.
What?
Well, find 2 and 4.
Okay.
And subtract it.
Good. Okay. What do I know about okay, we just said that 1 and 2 were congruent to each other, right? And he just said add 2 and 4 and add it to equal 180. What else could I do to find that top one besides the one that he said? So minus 2 and 4, not using 2 and 4. What could I do to find that top one? Yeah.
You could subtract 1 and 3 keep it the same. Because 1 and 2 are the same, 3 and 4 could be the same.
Right, so instead of using 2 and 4, I could use 1 and 3. Okay, because it's the same, right? This angle 2 was the same as 1, right? So technically, instead of adding these 2 to subtract, I could add these 2 and subtract because this is still a triangle, right? Okay, so you would get the same answer. You would figure out that problem. Okay. I think that was all. That was activity 1. It was all the stuff breaking down. Oh. This is, okay, so your second one down, it says under activity 1, write the triangle mid-segment conjecture. Okay, so we're filling in the blanks on these. If you didn't write it, we're writing it right now. Okay, so a mid-segment of a triangle, so that was this line right here, right, is what to this side? What do we see those guys are to each other? My red lines that I had on there. Parallel. Okay, so they are parallel to each other. You can just put the symbol if you want to, versus writing it out if you don't have space. So a mid-segment of a triangle is parallel to a side of the triangle and has a measure that is half of the side. So if I know the bottom number, I could divide it by 2 to find the mid-segment, or vice versa. I could double the mid-segment to find the base. Okay. We're going to come back to this one. This was at the very, very end of your notes. Okay. I think I changed the name. It was Jose in the book, and I think I put Daniel on your paper because at one point I had a kid in my class that I was bullying. So, okay. Next one. So on the next page on the back of your notes, says write the definition of a mid-segment of a trapezoid. So a mid-segment of a trapezoid is a segment whose endpoints are midpoints again, okay, of the non-parallel sides. And so what they mean is the sides that go in that are not parallel, those are the ones that you find in the middle of. And the reason why they say that is because sometimes they'll turn the trapezoid going this way. Okay? So we want to do it with the non-parallel sides. You don't want to do it here. Okay? Because that would not work out, okay, with the formula. So it wants to go from the non-parallel sides is where you're finding the midpoints. Okay, so we want to fill in what we did on the last one. So same thing as our triangle. We have this one and this one are going to be the same length because it's the middle of that side, the non-parallel side. And then this one and this one. And then fill in now 1, 2, 3, 4, 5, 6 into your drawing. Okay, so first thing, what do I know about this line, and this line? They're all parallel. Okay, so we're going to write a short statement. So we're going to put AB is parallel to MN, which is parallel to BC. Okay, what are you going to tell me about angles 1 and 2? They're the same. Okay, so let's write that statement on there. We're going to have angle 1 is congruent to angle 2. What would I know about 2 and 3? They add equal 180. So angles 2 plus angle 3 adds equal 180. Because this would be like the triangle if I could cover up that bottom part. These would be same side interior, same side, one's a cube, one's a 2, so they add equal 180. What would you know about 1 and 3? Right. So imaginary, if we could erase that middle one, that MN, right? You have the top one and the bottom one that are parallel. So really 1 and 3, if that middle line was not there, those would be the same side interior ones, so they would also add equal 180. Okay, it's just really replacing your 2 with the 1. Okay, so 1 and 3 would be. So the same thing's true then on the other side. So we're not going to write another statement for that. Okay, I think that answers. That was activity 2. So now I think we have another fill in the blank. Yes. Okay, so back to your vocab sheets. A midsegment of a trapezoid is what to the bases? And the bases on this, you have 2 bases. It's the top and the bottom when they talk about that. Okay. So that midsegment, what did we say was in comparison to those 2 bases? Parallel. Okay. So parallel to the bases of the trapezoid. And has a measure equal to, and we're actually going to write a formula here because we already wrote something on that first page. We're going to go base 1 plus base 2. Okay, we add those 2. Remember when we had the 7 and the 15, I believe it was. Okay, we add those 2 and then we divide by 2, which is finding the average of your bases. Because you have 2 numbers that you're dividing by 2. Okay, we're good? Okay, so here's an example of a problem that they had, and they want to verify, would this be the correct measurement for this one? Is that the correct measurement? So yes or no. What do I got to do with that top number and that bottom number? Add them, and then divide by 2. So that would be, is it right? Yeah, okay. Right. So when you add those 2, it gives you 95. If it didn't, there's one in the book assignment that's not. Then you state what the correct answer should be. Because it says, is this true? And if not, what should the correct answer be? So then you just write the correct answer. Okay. So last one, you were supposed to draw a chart You don't need to draw that. You had a chart that had DC, AB, MN, right? Okay. So what they're referring to is a trapezoid. Okay, that looks like this, and C is up here, and this is AB. They're wanting us to find the length of MN, fill in the chart. So what do we do with those two? Add them and then, okay, so if I added those and divided by 2, I would get 5, right, 5.5. Okay, so here, this could go 5.5. Okay, if I added those 2 and divided by 2, then this would be, add those 2, divide by 2, 4.5. Add those 2, divide by 2, it would be what? 6 and 2 would be 8, divide by 2 would make it 4. 6 and 1, you should probably see that pattern here. 6 and 1 is 7, divide by 2 would be 3.5. Okay, other than now they changed the pattern because it's not going down by 1. So if you added 6 and 0.5, because our numbers are getting smaller, 5, 4, 3, 2, 1, and divided by 2, you actually get 3.25. Okay, then adding those 2 and dividing by 2 gives us 3.05. Okay, in looking at your numbers, because you have these on your paper, so I don't have to scroll back up and down. What do you notice is happening with this number? As it's going down, it's approaching what number? What number is it getting closer and closer and closer to?
0.
No, not 0.
3.
3. Okay, so notice the base is staying the same. The base is staying the same. So that was this part. Okay. But this number, the middle one, is getting smaller and smaller and smaller. So it's actually going away from a trapezoid, and as that base on that trapezoid gets smaller, it's approaching a what? A triangle. So what do we know about a triangle and its base and its mid-segment? What did we do with it? The base, we divided it by its half. Okay, so we're approaching half as we're getting there. It's getting closer and closer to 3. Okay, where we wouldn't have anything left of that top number. Okay, so that's where the relationship between the two shapes come from. Really, the trapezoid is just a triangle with a cutoff, but as it gets closer and closer and closer, that's where the similarities connect. Okay, so the very last question. We're looking at a representation of what we just learned. Okay, so and I just covered my map. Daniel is on a school swim team. During the summer, he enjoys training at a small lake near his parents' cabin. To evaluate his progress, he needs to know the distance across the lake, XY. How can he use the conjecture you used on the other side of the triangle on ABC to describe how he could do that? Okay, so you've got a lake here that was drawn on your paper, okay, and then there's a triangle that's on there. Okay, he wants to try to figure out a way to figure out the length of that lake if you were to swim across that, if his cabin is up here. Okay, so that's his house. His house is up there. So think about the process that we went to find a base. So if he is at his cabin, what could he do with that left side? If, assuming he walks a straight line to the lake. He needs to find the what? The what? The midpoint, right? So if he were to walk from his house all the way down here to one side, he would know the length of how far he walked, right? So then he would do what with that number? Divide it by 2. Okay. So walking from one side, the left side, okay, of the lake, he would walk this distance and then divide it by 2. Okay, so what does he need to do to this side? Same thing. Find the distance from the cabin to the right side of the lake, and then divide it by 2. Okay, so now he has these divide by 2 things. What does he need to do with that? Say you labeled it something. We could label it MN if we wanted to. What did we do with MN to figure out so he doesn't have to swim across that lake? What did we do with MN? How did we find MN? From the other side of your paper. How did we find the distance from M to N? So if he marked on his trail the halfway mark, and then on the other side, mark the halfway mark. So he has these two halfway marks. What would he have to do in between the halfway marks?
Big break.
Yeah. It's a pancakes. Carb load. One more time. He's at his cabin, he walks, finds this middle point. Goes back to his cabin, walks, finds this middle point. What do we need to know about this to find this one down here? The distance, right? So his two middle points that he marked on his trail, right? He needs to find the distance of this. Okay, so whatever this distance is, without him having to swim, he's going to do what with that distance? Multiply it by 2 to find out how far across that lake is. So he would know, I can swim 2 miles, 3 miles, or whatever it is. Okay, so your assignment that you will hand in for tomorrow along with your reteach is in your own words. You're going to describe to me how to solve that if you were listening. Okay, so make sure to not leave any out parts. You're describing to somebody how to find that distance without him swimming.
On this or on the?
On the bottom, yep.